Right, and when I tried to review the lesson, I couldn't because there's no audio.
Oh, really? Wow, I didn't know that. Okay, well, that gives us more reason to stay on this.
Yeah.
All right. Let's go on to some advanced algebra. Well, it's not really advanced algebra, but that's what it's called in the GRE book.
Okay.
We're going to talk about inequalities now. An inequality is different from an equation, but it solves very similar to an equation. There's only one major difference. In other words, you're going to solve this inequality the same way you would solve if I replace that with an equal sign, except for one thing. If you ever have to multiply or divide both sides of the equation by a negative number, then you need to switch the direction of the inequality sign.
Okay.
Now, we're not going to have to do that in this one, but we will run into some where we do have to do that.
Mm-hmm.
So what's the first step here? What's the next line? What should I do?
3x is bigger than 60. And then we divide it by 3. X is equal to...
Greater than?
Yeah, x is greater than 20.
Okay. If you're going to use your calculator to do this, get to a point where you can do it extremely quickly. You know what I'm saying?
Okay.
Okay. That's the only way you're going to get by.
Okay.
I'm not saying that you have to master your multiplication and division tables, but the only alternative is if you can use your calculator quickly.
Okay.
Okay? All right. Now, let me think here. Yeah, let's try this one. That's less than or equal to. The way you pronounce that.
Yeah.
Okay.
Mm-hmm.
So what's my first step going to be here?
Minus x.
From both sides?
It's going to be minus x, so it's going to be minus 2x, right?
Correct.
Is less than or equal to...
Well, let's do that step first.
Okay.
In other words, until you become really proficient at this, I would suggest doing one thing at a time only.
Okay.
Okay. What's
then
that?
Minus 2x.
No, remember from this point, we're trying to isolate that. We already have.
Okay, so it's going to be...
we need to do something about that, and we need to do something about that.
Yeah, I'm trying first to put the numbers together on the... I think you're doing it like in the opposite way.
Exactly. Let's get rid of the plus 1. What do we have to do to move it to the other side?
Turn it to minus. So it's going to be minus... Yeah.
So what's the next line?
Minus 2x is less than or equal to 62.
And the final line?
Divided by 2, which is
divided by negative 2?
2, yeah.
What do we have to do every time we divide or multiply by a negative number?
We turn the sign.
So it becomes greater than or equal instead of less than or equal.
Yeah.
What goes on the other side?
Minus 31.
Good. Okay. Looking for something that might challenge you a little bit. Yeah, I don't want to give you something too easy. Let's look at when we have three things. What do you suppose the first step should be here?
I don't know. Divided by 4?
Well, not divided by. Remember, you have to do the opposite of what that 4 is. We're talking about this 4 right here, okay?
Yeah.
We want to get rid of it.
Yeah.
So right now, it's adding to x. So what do we have to do to it?
Multiply it by...
Subtract, the opposite of adding.
Okay.
So I want to subtract 4 from the middle, which means I have to subtract 4 from there, and I have to subtract 4 from here. Now, I do not turn the direction of the inequality signs. I am not dividing or multiplying. I am merely subtracting. Okay, so the left turns into a 2. The middle turns into x, which is what we want. And the right turns into 0.
Yeah.
So what this says is that x has to be greater than 0 and less than 2. Let's draw a number line, because sometimes these can be helpful in figuring out where x can be. Okay, that's where x can be. And typically they put circles to show that it's greater than or less than, as opposed to if this was like that, they would be closed circles. In other words, if it could be 0 or if it could be 2, we would have a closed circle. But if it has to be greater than 0 and less than 2, then we're going to have an open circle in our graph. Okay. Just basic algebra. Solve for x. How do I solve for x? Which means I have to get rid of the a and the b.
Subtract it?
No. What are the a and the b doing right now?
Multiply it.
Exactly. So what do I have to do to get rid of them? What's the opposite of multiplication?
Divide it?
Yes.
Okay.
So if I divide by AB, I have to divide both sides. Now, those cancel and I'm left with x equals C over AB. Excuse me, that looked like an E. Let me draw it as a C. Okay?
Yeah.
Okay. Always remember, that's the secret to solving equations, is you do the opposite of what it is currently doing.
Now,
This is a little harder. Solving for x. What should the first step be? Whenever you're solving for a variable and you only have one variable. In this case, incidentally, that's a constant, that's a constant, that's a constant, that's a constant. The only variable is x. So, along the way, when learning how to solve equations, you learn that at some point You gather all your variables on one side of the equation and all your constants on another.
Mm-hmm.
So let's do that. Let's get every term that has an x in it on the left side of the equation, and every term that doesn't have an x in it on the right side of the equation.
So it's going to be a minus c is equal to...
I personally prefer to put my variables on the left side.
Okay.
Oh,
Yeah.
hold on, excuse me. That means c minus a.
Yeah, c minus a.
Okay, and what goes on the left side?
dx minus dx.
Good. Now, we're trying to isolate x.
Uh-huh.
I can do it, but not immediately. In other words, I don't know what bx minus dx is.
Mm-hmm.
I don't know what b and I don't know what d are. If these were numbers, I'd be able to do this math. But there is something I can do. What is it? Always be thinking factoring. Yes, divide by what?
By b and d. So the first one we divided by...
No, we're dividing by x. What we're really doing is taking out a greatest common factor. Remember greatest common factoring?
Yeah.
We're going to take out an x.
Mm-hmm.
What do I leave behind when I take out the x?
b minus d.
Correct. Okay, now we have this. And now how do I isolate x?
Divided by x.
Not divide by x, but divide by what?
B minus d.
Correct.
Okay.
If I do that on the left, I got to do it on the right. Now I cancel, and I get x equals that.
Yeah.
And these are the four constants, notice. So whatever c or a, b, c, and d are, I would plug them in there. But this is still a relatively hard algebra problem to solve for x. Okay. Let's solve this one for x. Remember the first rule of solving equations. Get rid of denominators, get rid of parentheses.
Yeah.
How do I get rid of the denominator?
We multiply it by x. No, by b plus cx.
Correct.
Yeah.
Since I'm doing that to the left, I got to do it to the right.
Yeah.
Now, what do you have? What's the next line read?
It's going to be ax is equal to b plus cx.
Okay.
Yeah.
Now, remember the middle step of solving equations? What's the next line, or what's the next step?
Yeah. Ax minus cx is equal to b.
And the next step?
Divided by x.
Okay. Give me the next line.
A minus c.
Let's put the x first, because what we're really doing is factoring out the x.
Okay. A minus c.
Yeah. In other words, as you do these steps, always make sure that you're not changing anything.
Yeah.
In other words, after I multiply this back together again, it better be the same thing as that. And it is.
Yeah.
And that's equal to b. So what is x equal to? What's x being multiplied by right now?
A minus c.
Okay, so what do we need to do to isolate x?
Divide it.
All right. In other words, I
So,
got to divide both sides by a minus c.
so x is equal to b over a minus b.
Yes. Huh?
Yeah.
Gosh, who knew algebra was easier than number theory or than arithmetic?
Yeah.
All right, now we're going to talk about solving two equations and two variables. In other words, if I have this equation alone, I cannot solve it because x could be 1, y could be 1, x could be 0, y could be 2, x could be minus 1, y could be 3. There are literally an infinite number of solutions to this. However, if I add a second equation that's different than the first, and that's a key thing, it has to be different than the first. Now, because I have two equations and two unknowns, I can actually solve for both of them. Now, how do I do that? Well, there's two different methods they have. One is called substitution. And the other is called elimination. Let's talk about the elimination. Okay? One of the things you can do if you have equations is you can always add them together or subtract them. In other words, if I tell you that a plus b equals c, and also x plus y equals z, then you can add those two equations together to get a plus b plus x plus y equals c plus z. That is something you can always do by the nature of equations. You can also subtract them. A plus b minus x plus y equals c minus z. Okay? So you can add or subtract. You cannot multiply them. You cannot divide them. You cannot square them. It's not like solving an equation where you can do anything you want to one side as long as you do it to another. You can only add or subtract equations.
Okay.
So, the way we're going to solve this equation is by adding the two equations, and we're going to utilize this method right there, elimination. And what eliminate means is that one of the variables is going to disappear. We're going to eliminate it. So if I add these two equations, what do I have on the left side?
2 plus...
What's x plus x?
2x.
What's y minus y?
Minus 2y.
What's anything minus itself? Always.
0.
0, exactly. I've just eliminated the y.
Yeah.
What is 2 plus 4?
6.
So what's x?
6.
Now we still have to solve for y. In other words, the goal here is to solve for both variables. Well, we solve for one of them. X has to be 3. Well, how would we solve for y? Substitute back into one of the equations.
Okay.
Okay. Well, let's go into the most straightforward equation, the one that's got plus signs and small numbers. So let's substitute x equals 3. So we have 3 for x plus y equal 2. What does y equal?
1.
No.
And 1.
What'd you say?
-1?
Correct. Did you do that on the calculator?
No.
Okay. I didn't care if you did.
Yeah.
It's okay with me. If you can do this with a calculator, I'm going to be really impressed. It's just that I have a pretty strong belief that it's almost impossible to do this with calculators.
Yeah.
There are just too many little calculations you have to do. And it's too slow. It takes you an extra 5 to 10 seconds each time you have to do one of these with a calculator. So my belief is that you really need to be able to do single-digit math in your head. Okay? Now, that means we solved the equation. We got x equal 3, y equal -1. And you'll notice that if we go back in and stick it into either equation, it is correct. And even if I stick it into this one. So I've checked it. In other words, by verifying the two answers in both equations, we know that that's correct. And that is the only solution for x and y.
Can we do y again, how we solve it for y?
Yeah. Once I got x equal 3, I'm going to go into that equation and substitute what we got for x, which is 3. So it becomes 3 plus y equals 2 instead of x plus y.
Yeah.
Because we now know what x is. X is 3. So by substituting in for x, we can now we have one equation, one variable. You can always solve those. Okay? All right. Now, there's another method for solving to a system. It's called a system of equations. Okay? That's what we have here, is a system of equations. But instead of this being the second equation, I'm going to manipulate it slightly and make it look like this. Same equation, notice, is all I did was add y to both sides. You with me?
Yeah.
Okay. So now, instead of having the two equations I originally had, I've got one that looks the same way, but another that's already solved for one of the variables. Doesn't matter whether it's for x or for y. One of the variables is fully solved for. Now, instead of using elimination, we're going to use substitution. And it's exactly what it says. We're going to substitute. We're going to go into this first equation, x plus y equal 2, and in place of the x, we're going to put that, because that's what x is equal to. Now we have one equation, one variable. We're going to be able to solve for this. Very important to understand that once you get it down to one variable and one equation, you can always solve for it. Let's solve for y. Remember the first step? Always eliminate parentheses and denominators.
Yeah.
So can I just erase those parentheses?
Yeah.
I can. The only reason I put them in there in the first place was to make the problem more understandable as to what I was doing. In other words, I was substituting for x, so I put parentheses around it, because that's what x was equal to. But when I go to the next step of the equation, those parentheses aren't needed.
Yeah.
So now what? Solve from there.
It's going to be y 2y
Okay.
is equal to 0. Not 0. 2 minus 2. Not minus 2. It's yeah. 2.
Minus 2 is correct. In other words, what you're going to do is subtract 4 from both sides.
Yeah.
We got to get rid of that 4. You added the y's together properly, but now we got to move that 4 to the other side, which means we got to subtract 4.
Yes.
That gives us minus 2. What's the last step?
Y is equal to 0. Is it 0?
What do we have to do to the y to get it by itself? Always the last step is to divide by that coefficient.
Yeah, minus 1.
There you go. Same answer as we got when we did it the other way.
Yeah.
Okay, now we still have to solve for x. We know, excuse me, that's what x plus y is equal to. So how do we solve for x? Once we've solved for y, that's only half the job.
X plus minus 1 is equal to 2.
Keep going.
X is equal to 1.
No. In other words, let's do an intermediate step here. Let's get rid of the parentheses. How do I get rid of those parentheses? What do I have to erase? If I'm going to erase the parentheses, I can do it. Now, which sign do I erase?
The positive.
Exactly.
Yeah.
So now I have x minus 1 equals 2. Now how do I get rid of the minus 1?
Divided by minus 1.
No, it's subtracting. Always do the opposite.
Yeah.
Remember that multiplication and division are the opposites.
Yeah.
And addition and subtraction are the opposites. So if it's subtracting, you have to add. If it's multiplying, you have to divide. If it's dividing, you have to multiply. If it's adding, you have to subtract. So those are your 4 options, really. But the key is to do the opposite of what it is currently doing. So I have to add 1 to both sides, which gives me x equals 3.
Yeah.
Same 2 solutions we got doing it the other way. Now, the only difference is the other way was the way that the 2 equations were presented to us. In other words, if they're presented to you like this, that's considered standard format. And by subtracting or adding these 2 equations, we're going to be able to eliminate one of the variables. If the second equation is given to you like this, instead, where y is completely defined, or like this, where x is completely defined, then I can use substitution. When I use substitution, I will take one of the equations and change it from 2 variables to 1 variable. And as soon as you get down to 1 variable and 1 equation, you're going to be able to solve it. Okay? So this is considered standard format. An example might be the following. 2x plus 3y equal minus 4x plus 5y. And I'll put the number 10 over there and the number 20 over there. Okay? So here I've given you two equations, two unknowns, x and y, and they're completely different equations. And I'll get to that in a minute. They don't have to be different equations. But I'll give you an example of two that are not the same.
Yeah.
Okay? However, what we're going to do here is notice that if I add or subtract these two equations, I do not eliminate a variable. Okay?
Yeah.
However, the rules of algebra say that you can multiply any equation by something on the left as long as you do it on the right. Notice what happens. I'm going to label these equations, 1 and 2. I'm going to take the top equation and I'm going to multiply it by the number 2, which means I have to multiply the right side by 2.
Yeah.
And what it becomes is really the same equation. It's just 2 times bigger on both sides.
Yeah.
Okay? Now, that's my new equation 1. I'm going to erase the original one. I'm going to erase that line. And notice that now, if I add the two equations, what variable disappears?
The x.
Yeah, that's what we're trying to do. In other words, I'm always going to choose a multiplier that causes one of the variables to disappear.
Okay.
That's my goal, is to eliminate one of the variables. So if we add these two equations together, what do we get?
11y is equal to 40.
And y is equal to 40 divided by 11.
Yeah.
Now, I made this one up off the top of my head, so it doesn't come out to nice round numbers, but you can still take your y answer and go into either equation, substitute that y for that y, and solve for x. Okay? In other words, once you solve for the first variable, you will always be able to solve for the second one.
Yeah.
That's not the problem. Okay? And let's take one more example of elimination. Uh-oh, if I don't talk for a minute, that sound comes on, so I'm just going to kind of babble along. Okay? Now, you can see that if we add or subtract these two equations, nothing gets eliminated.
Yeah, so we have to, okay. So it's going to be...
multiply one of them by... Now, I could multiply the top one by 1.5. And that would make this 3x. But you don't want to use fractions if you can avoid it.
Yeah.
So let's multiply the top equation by some number and the bottom equation by a different number, such that we will be able to eliminate one of the variables. What numbers can I use?
Oh, is there a specific number that I have to use?
Well, kind of. In other words, my goal is to eliminate one of these variables. Let's pick x.
Okay.
Notice that if I multiply the top by 3 and the bottom by -2, I'm going to end up with 6x and -6x.
Okay.
Then when I add the two resultant equations, my x's are going to disappear. Now, I could also multiply it by 6 and 4, same thing. But you're looking for kind of, it's a least common denominator kind of thing.
Yeah, but in some situations we only multiply only one equation, like the last question.
If you multiply, yes, exactly. The last equation, I only had to multiply one of them.
Okay.
But in this one, I got to multiply both.
Yeah.
And of course, if I multiply the left side of the top equation by 3, I got to multiply the right side. I'm going to multiply the left side of the bottom equation by -2. Going to multiply that by -2.
Mm-hmm.
So let's rewrite equation 1 and equation 2. What is the new equation 1?
6x plus 9y is equal to 15.
And 2?
Minus 2 multiplied by 3 is equal to minus 6. Minus 6x plus minus 10y is equal to minus 30.
What'd you say?
30.
When you're multiplying a number by 10, is all you have to do is add a 0.
Yeah, 20.
Okay?
I was looking at 15, yeah.
Now notice that we've got the equations perfect for eliminating a variable. What do I have to do to eliminate a variable?
Subtract it, yeah.
Not subtract them. Add them.
Adding, yeah. It's going to be x.
In other words, yeah. Well, now hold on. When I add these two equations, that's what I'm doing.
Yeah.
Okay, the first step is to add the x terms. What's 6x plus a minus 6x?
0.
Exactly, that was our goal. We were trying to eliminate the x. What's 9y plus a minus 10y?
Minus 1y.
And what's 15? Well, I can say this either 15 plus a minus 20, or I can just say 15 minus 20. What's the answer?
Minus 5.
So what's y equal to?
Minus 5.
No, minus y is equal to minus 5. How do I isolate y?
Divided by, divided by minus y?
Minus 1.
Oh, okay.
In other words, this minus y is the same as minus 1y.
Mm-hmm.
So I'm really going to divide by minus 1, both sides of the equation, and I end up getting y equals plus 5.
Yeah. And what's the question for that kind of equation? What's the question is going to be?
Solve for both variables.
Okay.
Okay? And we just solved for one of them. You have to solve for one of them at a time.
Mm-hmm.
Now we got to solve for x because we solved for y. Doesn't matter which one you solve for first.
Mm-hmm.
We solved for y. Now we're looking at 4 equations here. We're looking at this number 1, this number 2, this number 1, and this number 2.
Yeah.
Let's go back to the original equation before I multiplied both sides by 3. And this original equation before I multiplied both sides by minus 2. And you always want to go to the easiest equation to solve for x. Well, these two equations down here are bigger numbers all the way around.
Mm-hmm.
Always go to the equations with the smallest numbers.
Mm-hmm.
I'm going to erase these two here, which were merely multiples of that. And I'm going to say, okay, y is equal to 5. That's what we discovered. So which equation would you substitute in for to solve for x? Number 1 or number 2?
Number 1.
Yeah, it's smaller numbers even than number 2. It's, you know, the biggest number in this is 5. Down here we got 10s, 5s, and 3s. So let's substitute. Tell me what to write.
2x plus 15 is equal to 5.
Next.
2x is equal to 5 minus 15
Give me a number.
Minus 10.
Next.
Divided by 2, the both sides.
Give me a number.
The number is going to be minus 5.
Okay. So all I'm trying to do is get you practiced to doing that on your calculator quickly.
Yeah.
Okay? Because that's the only way you're going to make this work, is if you get to a point where you can come up. In other words, you can't give an answer like minus 10 divided by 2.
Mm-hmm.
You're not allowed. They're always going to want it in simplified format.
Yeah.
So you always have to do that division.
Yes.
Okay? So, and there's our two answers. We've solved for y and we've solved for x.
Yeah.
And that's always the goal. And
so solving for the first one is going to be the harder. Then when we figure out...
Yeah, once you solve for the first one, the second one is relatively simple because now you just have one variable and one equation.
Uh-huh.
It's the system of equations. In other words, that's what this is called, is a system of equations.
Mm-hmm.
It can even be 3. In other words, you could have 3 variables and 3 equations.
Mm-hmm.
As long as you have the same number of equations as you have variables, you're always going to be able to solve it.
Mm-hmm.
It's harder if I add a third variable like z and a third equation involving z.
Yeah.
It takes a lot longer. It's like a 20-minute problem.
Right.
Don't think you're going to run into any of those on the GRE. They don't give you that level of difficulty. But you do need to know how to solve a system of 2 equations and 2 variables.
Yeah.
Now, I said, I'm going to change equation 1 around so that it reads like this. Notice is all I did was subtract 3y and divide by 2. Okay?
Mm-hmm.
And then I'm going to erase the equation 1. Now, this is still a system of equations. The thing is it's not in ready format for solving by elimination. But it is in ready format for solving by what method?
Substitution.
Yeah. And how am I going to do it? Which equation am I going to substitute into for? 2 or 1?
2.
Correct. What am I going to substitute and where?
The x.
Okay. So anytime I see an x, what am I going to write?
5 minus 3y over 2.
And then I still got to add this 5y. It's still equal to 10. But now notice I have one equation and only one variable. I've gotten rid of the x. Even with substitution, you eliminate one variable when you substitute. Okay, now this is a little bit of a tricky equation, so let's solve this. It illustrates a number of things that you want to do when you solve an equation. What's the first thing I want to do here?
Eliminate the parentheses.
Sorry, what? I didn't hear.
We have to take out the parentheses.
Okay. How do I do it?
So it's going to be 3, 5. It's going to be 15.
Read the next line to me.
Okay. 15 minus 9y over 6. 2.
I'm only multiplying numerators.
Yeah.
Okay.
5y.
Plus 5y. I need the plus sign.
Yeah. Is equal to 10.
Okay. And what's the next line?
Multiply it by 2.
Okay, now, this is a little tricky. When I multiply by 2, I have to multiply the entire left side by 2.
Okay.
Not just this term. Because that's the rules of algebra. You can do anything you want to one side of the equation as long as you do it to the other, but you have to do it to the whole side of the equation. You can't just pick out pieces of it. I can't just multiply this side by 2 without multiplying that term by 2.
Uh-huh.
Now what do I have? What's the next line?
30 minus...
Hold on. The reason I multiplied by 2 is because that was going to be able to cancel with that.
Yeah, right.
Well, let's not make it 30. Let's do the cancellation.
Mm-hmm.
So when I multiply this by this term, what do I get?
15 minus 9y.
Easiest way to do it. When I multiply this by that term, what do I get?
10y.
Plus 10y equals
20.
Now no more parentheses, no more denominator.
Yes.
Very easy problem now. Combine your y's, put all your numbers on the other side. What do you got?
Minus y plus 10y.
Minus 9y plus 10y equals what? When I say simplify that, combine them.
It's equal to y.
What are the numbers equal to?
5.
Correct.
Yeah.
Okay? And that, again, is the same solution we got when we did it by elimination. That's because I didn't change anything. I just rewrote this.
Yeah.
Okay? So we better have got the same solution. The only reason I rewrote it was to show you the second method for solving a system of equations. It all depends on what format they give them to you.
Mm-hmm.
In other words, if one of the equation is already solved for one variable, then you almost certainly are going to use substitution.
Yeah.
If both of them are in standard format, meaning your x and your y are on the same side of the equation and your number is on the other side, that's called standard format. It's written like this: ax plus by equals c. That's standard format. If both equations are given to you in standard format, then the best way to solve them is almost always by elimination.
Yeah.
All right. Now, there's a couple caveats to this. Let me explain what they are. If I say x plus y equals 10, and then I give you a second equation that says 2x plus 2y equals 20, you might think that, well, I have two equations and two unknowns, I should be able to solve this. But you can't, because the second equation is not an independent equation. All it is a multiple of the first equation. I have not given you any additional information when I wrote that equation. I could have taken the first equation, multiplied both sides by 2, and I would have gotten this equation.
Zeros.
Well, if I try to solve this, and the way I would try to solve it is multiplying the top by minus 2. So I got minus 2 minus 2y equals minus 20. And now when I go to add the equations, I get 0 equals 0. So I don't solve for anything. And I can't, because I don't have two independent equations.
Right.
You have to have a separate, different equation. It cannot just be a multiple of the first one. Also, if x plus y equals 10, then it's impossible for x plus y to also equal 9. Notice that if I tried solving this using subtraction, I would get 0 equals 1.
Mm-hmm.
When you get a number equals a different number, that means that there was really no solution.
Okay.
Okay? And there's no solution because these two equations are contrasting one another. You can't have x plus y equal to 10 while at the same time having x plus y equaling 9. Just, you can't do it. And now if I wanted to say x minus y equal 9, that's fine. That works perfectly well. And notice that that's a completely different equation than the first one.
Mm-hmm.
How would I solve this? Do it by elimination because both equations are in standard format. Which variable am I going to be able to eliminate? The easiest way, which is always by adding. In other words, subtraction is allowed, but most people don't like subtraction. They don't handle it real well. So you're always better off adding if you can do it. If I add the two equations right now, what variable goes away?
Y.
Correct. So let's do that. What's the bottom? What goes below here?
2x is equal to 19.
Which means x is equal to 19 divided by 2.
Yeah.
Now, the only time I give it to you like that is when it doesn't turn into a whole number.
Uh-huh.
If that would have been 20 divided by 2, I would have said 10.
Yeah.
I would never have said 20 divided by 2.
Yeah.
But 19 divided by 2 is actually equal to 9.5, the proper fraction. And then, if there's a fraction involved, I would rather give it as an improper fraction, 19 halves.
Uh-huh.
In other words, I prefer that answer to 9.5. But if you can simplify it all the way down to a single integer, a whole number, then that's what you want to do. All right, let's do the next one in the book. I've been winging it for a half an hour here, and the reason is that I've covered this subject so many times that I feel like I know how to do it better than the textbook does. Now, or not the textbook, but I have all the sample problems in my head already.
Yeah.
So are we going to solve this by elimination or substitution?
By elimination.
Correct, because it's in standard format.
Yeah.
Now, which variable can I eliminate?
X.
Okay, by doing what?
Subtracting.
Exactly. I'm going to subtract the two equations.
Yeah.
What do you get for an answer?
0 plus.
I'm going to subtract 1y, positive 1y, minus 3y. What do you get?
Minus 2.
Minus 2y
9.
equals,
Minus 3.
okay. And then y would equal positive 3 halves. Now, notice that I can actually do this a little easier if I take equation 2 and subtract equation 1. I don't have to rewrite it, but I will just for sake of clarification. I'm also allowed to subtract in either order. Notice that if I subtract now, I deal in nothing but positive numbers.
Mm-hmm.
That's always an advantage. I get the same answer as I would expect to get, but there's no negative signs.
Mm-hmm.
The first time I had a y minus a 3y, that's an opportunity to make a mistake, but if you have 3y minus y, you're not going to make a mistake on that nearly as often.
Right.
Okay? So when you have a choice of dealing with positive or negative numbers, and one has all positives and the other has all negatives, try to go with the way that uses positive numbers. Just remember that when you have these two equations, you can subtract them in either order. Adding them in either order is obvious. It doesn't matter. Whether I add 1 to 2 or 2 to 1, I get the same answer. But subtracting them in reverse order gives you a different answer, but it's the same answer. It's just different looking on the paper.
Yeah.
All right, let's see. We've got one more here that the book has, and this is one that I kind of talked about a little bit. How are you going to solve this?
Substitution, elimination.
Okay.
21, 21.
How are you going to eliminate a variable? First of all, tell me if you're going to add or subtract, and if you're going to subtract, in what order?
We're going to subtract.
Okay, which one from which one?
So we're going to subtract the second one from the first one because it's easier.
You said that wrong, but I know what you meant. You're going to actually subtract the first one from the second one.
Yeah, what I mean.
Yeah, you're going to take equation 2 and subtract equation 1.
Exactly, yeah, that's what I mean.
Right, and what that verbally means is you're subtracting equation 1 from equation 2.
Yeah.
Okay, so what's the answer when you do that?
3y is equal to 0.
So y is equal to what? What's your calculator say when you take 0 and divide by 3?
0.
That's always it. If
Okay.
you're dividing into 0, it's always 0, no matter what.
Okay.
Okay? In other words, that's one you definitely could save yourself a lot of time by memorizing.
Right.
Okay? Now, if I substitute to solve for x, what do I get? Let's substitute into equation 1.
Mm-hmm.
Substitute 0 for y and rewrite the equation.
Okay, so I'm just going to give you the final answer, which is...
Well, no, give me the whole equation. 21x plus 7 times 0 equals 3. And this is kind of the way I'd like to see you do it every time.
Okay.
In other words, do it the long way. Won't make any mistakes. What's the next line?
21x is equal to 3.
Okay, and the next line?
X is equal to x.
3 over 21. Now see, that's not the easiest thing to simplify on a calculator.
Yeah, we cannot do that. Oh, okay.
You have to kind of know your multiplication and division tables to know that that is simplifiable. What can I divide top and bottom by? 3.
3. Okay.
3 goes into 3 one time. 3 goes into 21 7 times.
Okay.
But in all honesty, I don't know how you'd get that from a calculator, especially the calculator you're going to have on the GRE.
Yeah.
No way you're going to know how to convert 3 over 21 into 1 over 7 unless you learn your multiplication and division tables. And a lot of factoring is like that. In order to be able to factor, in other words, if I told you to factor the number 45, to me, I know that's instantly 9 times 5. But I doubt that you knew that.
Yeah.
Because unless you know your multiplication tables, you're not going to know that.
Mm-hmm.
So it's very difficult to factor with a calculator. And yet that's one of the skills you really need to be able to do. So I still recommend you go to A+ Math and just practice your multiplication and division tables. There's some you're going to be able to get half by using a calculator if you learn how to use it quickly. But there are some problems where not even that is going to help you do this without knowing your single-digit multiplication and division tables. They're not really that hard to learn. If you think about it, there's only 100 of them. There's 1 through 10 this way, and there's 1 through 10 that way. And if you do all combinations, you end up with 100 numbers to memorize. But then you'll know them forever. In other words, 1 times 1 is 1, and that's square. 2 times 2 is 4, and that's square. 2 times 1 is 2, and that's square, and so forth. Mm-hmm. But learning those multiplication and division and addition and subtraction, I just think is a necessity in math.
Yeah.
All right. Munira, I will talk to you next time. And I'm glad our sound held out. You should have audio when you get this file. And I'll talk to you next time.
Thank you.
You're welcome. Bye-bye.